Hello engineers, welcome to 18th lecture of ASME BPVC Section-VIII Division-1 Code Training. That is UG29 stiffener rings for cylindrical shells under external pressure. Today we discuss about theory part about stiffener rings guys. That is part A. In upcoming session we will discuss about part B, that is calculation part. Okay, so let's start this session guys. Before going to stiffener rings calculation or stiffener ring theory, let's recall the previous lecture. That is UG28 thickness calculation under external pressure. So we know that if PA is greater than P, our design is safe. PA means maximum allowable external working pressure and P means design pressure. If maximum allowable external working pressure is greater than our design pressure, then our design is safe. So no need to do any further calculations here. Okay, but if maximum allowable external working pressure is less than our design pressure, that is P, our design is not safe. So here we need to find the optimum solution to pass the design. So what are the optimum solution guys? So one is increasing the thickness throughout the shell and another one is adding stiffener rings. So this is our pressure vessel. So which is having L as a unsupported length. Okay. So for this our PA is less than P. So our design is not safe. So we have two optimum solution. One is increasing the thickness. Either we need to increase the thickness throughout the shell, okay, or we need to add the stiffener ring, guys. So if we increase the thickness, weight of the vessel increases, and also manufacturing time also increases, and the cost of the equipment increases. So the preferred option is to add stiffener rings, guys. So we need to prefer option B to add stiffener rings as a adequate solution for pressure vessel. Okay, so the stiffener rings acts as a line of support and divide the unsupported length into equal parts. Here you will see that. So this is unsupported length, total length, right? So here by adding this stiffener ring, total unsupported length is divided into two parts, right? That is L by 2 and L by 2. So here stiffener ring provides extra strength to your pressure vessel. Okay, I hope you understand my point. So here you can see the diagrammatically representation of your stiffener ring and your pressure vessel. So is adding too many stiffener rings is good choice? So if you know the answer, just comment your answer in the comment section, guys. So my answer is adding too many stiffener rings may not be the good choice, guys, because welding may not be good for vessels, right? So if you want to attach a stiffener ring to your vessel, you need to weld, right? You need to weld in between them. So by adding too many stiffener rings, we need to weld in too many locations. So which is not good for our pressure vessel. Why? Because welding creates additional stresses, right? So the stresses is not good for our pressure vessels. So adding too many stiffener rings may not be the good choice because welding may not be good for our vessels. So in that case, a combination of increasing thickness slightly and adding stiffener rings may be the adequate solution. In that case, we will add a small amount of thickness and we will add stiffener rings. So both combination of stiffener rings and thickness. So it will be the good choice for our larger vessels. So where too many stiffener rings may not be the good choice. How stiffener rings help to make the design adequate? Still now we see what is the purpose of stiffener ring and what is the use of stiffener ring. Okay, so now let's try to define how stiffeners help to make the design adequate. We know that if PA is less than P, our design is not safe, right? So what will happen in that condition? So due to external pressure, buckling will happen, right? So how to reduce this buckling? I know that buckling depends on the slenderness ratios, that is L by D and D by T ratios. If you do not know about slenderness ratios, L by D and D by T ratios, please watch UG28 section, guys. I already recording will be there in my YouTube channel, so please go and watch there. So if you like my content, please subscribe my channel and share to your friends also. So that will be boost my energy levels. So thank you. So if I reduce the L by D and D naught by T ratios, failure chances decreases, right? Because buckling will depend on L by D and D by T ratios. So that's why I added here stiffener rings. You can see internal stiffener rings and external stiffener rings. You can use either internally or externally by welding to the vessel. So that's why I added the stiffener rings here to reduce the unsupported length into equal supported lengths. Here you can see, so before we see that there is no stiffener rings, right? In that case, our L is from here to here. Yeah. Now I divided by adding the stiffener rings, I divided the unsupported length into equal parts. So you can see here, here also. So I hope you understand my point. So here H by 3 means what, guys? So we know that as per code, these dished heads also acts as a stiffener ring. So this length also acts as a stiffener ring. We need to consider this length also. So okay, from shell to head connection to H by 3 distance. Okay, this will act as a stiffener. We need to consider this length also while calculating the moment of inertia for the stiffener rings or whatever it may be. So we know that by adding the stiffener rings, total unsupported length is reduced. By reducing the unsupported length, L by D ratio decreases because if we decrease the L, automatically this slenderness ratio also decreases. Due to decrease in L by D ratio, then factor A increases, guys. So how to find out factor A? If you go to ASME BPVC section 2, subsection B, sorry, subsection C, you will find figure G, guys. So from there you can find factor A value by using this L by D ratio. If factor A increases, automatically factor B increases. So factor B also increases. By increasing the factor B, your maximum allowable working pressure also increases. Let's see how. We know that PA is equal to 4B by 3 into D naught by T, guys. So here B is directly proportional to maximum allowable working pressure. If you increase the B value, then automatically your withstanding pressure also increases for your material. So this is how your stiffener ring help to make your design adequate. So finally we understand the how by adding the stiffener ring will give adequate design. So I need to tell two more points before ending this session, guys. What is the distance between stiffener to stiffener ring, guys? So how much distance is allowed for stiffener to stiffener ring? So the code given that for up to 8 feet, the space between one ring to another ring, that is center of one ring to a center of another ring, is 2D for up to 8 feet. For above 8 feet, the ring spacing is D, guys. So let's see with example. So this is the figure G, guys, figure G charts. So this is the factor A values. So we already know the L by D ratio. So let's see in practical way, guys. So this is D naught by D ratio. For example, our D naught by D ratio is equal to 100 and our L by D ratio at starting is 20. For example, guys. So if you connect the boat, this is our A value, right? If you draw vertical line, so this is our A value. That is 0.0001, guys. So at starting, if we reduce the L by D ratio, if we reduce the L by D ratio to 4, then our d by d ratio is 100. If you draw a line, if you connect the line, so this is our A value connecting point. So if you draw a vertical line, you can see here your A value is 0.0003, guys. Okay, so by decreasing the L by D ratio, the A value increasing, right? So this is how we stiffener rings helps to uh, increase the strength of your vessel. So if A value increases, B value automatically increases. If B value increases, your allowable external working pressure also increases. So next we will discuss about what are the types of stiffener rings. So what is the shapes? What are the shapes we need to use? Generally industry will use. So let's see that. So types of stiffener rings. One is bar type. This is the first one. That is bar type, guys. This is bar type. So first one is bar type or ring type, and next one is T type, and next one is I type, guys, and next one is angle type. So these many stiffener rings generally used in most of the industries. So which stiffener rings generally we use? So how do we choose which stiffener ring is better, which shape is better for our pressure vessel? So which type of stiffener ring will be selected? If you know the answer, then comment your answer in the comment section. In next lecture, we will see the which type is better to use with calculations. So if you like my content, please subscribe my channel and click on the bell icon. You will receive notification if I upload any new videos, guys, and hit the like button also. So please share to your friends, so I will also get benefited. So I'm targeting the 100 likes for this video. Thank you guys.